Hey, welcome to episode 3. And for today, what we're going to do is validate the vision. And first, understand that when you have a vision and a dream, that's fantastic. It's awesome. And it should be quickly analyzed like, hey, is this a feasible thing to do? Is it possible? Okay. And then what I like to do then is just now that I have this vision, I need to validate it before I get in deep into the planning or just start. I need to kind of validate that. Okay, so I'm doing things a little bit out of order of, say, your typical project planning where you determine the business case, which we've done in a way. We've said what we want to do and why we want to do it and all that, and to include some specifics like generating a lot of food for our family, implementing a nursery for a stream of income, etc. And then after you would do things like that, so right, you make a business case, then you would go through and determine the vision, the goals, the objectives, and the scope. Okay, and so we've kind of done that, right? We wrapped all that up into the vision for the project, which includes the business case and loosely the scope and the objectives and the goals. Okay, now, but before I go further and before I really outline those things, I want to validate the vision. In other words, I want to say, okay, is this even possible, right? Am I way off on budget? Am I way off on what it's going to take to do it? I need to count the costs. Okay, and now for today, again, it's kind of like validating the vision. So we're still in this kind of conceptual framework. Conceptual mode, and that's what we're going to do. So we're going to look at things like the site considerations and see if it's possible, and then we'll get into more specifics and detailing and tasking and scheduling and all of that. Okay, so for today, we're validating the vision. One of the most important aspects of any passive solar design or cold climate greenhouse in this case is siting and orientation. Basically, how are you going to orientate the structure? In North America, 85 to 90% of all solar radiation comes from the south. Therefore, we need to make sure that we are oriented properly south. And as you can see from this picture, we are. I am standing and taking the shot from a position of being inside of the cold climate greenhouse. This shot, also oriented to the south, shows the sun path at the equinoxes, so March and September 21st-ish. This shows us what type of sun that we're going to be getting at these times of year, at these kind of critical shoulder seasons. This is a look to the east, and it shows once again at the equinoxes that sun path. So when at what point in the day are we going to start getting sun inside of the cold climate greenhouse? And this is very helpful in placement and planning. This is a westerly shot showing again at the equinox where the sun is coming down. And on this side, one of our main concerns is shade. We want to build up shade on the west side, especially when it comes to summer. Not so much at this angle, but as you'll see when we get into summer solstice, this is where it becomes critical. Here again, an easterly shot, this time at summer solstice. And so we can see the sun is much higher in the sky with a whole lot more sun. And we need to be concerned now with ventilation more than anything else. Southerly exposure at summer solstice. And again, what we need to watch here is being too hot. And so what we want for glazing, we do not want a perpendicular angle to the sun in the summer. We want something less than that. We want more perpendicular towards the equinoxes. Westerly look at summer solstice. You can see how much later in the day the sun is out, and this is why the west side of the cold climate greenhouse is going to be fully insulated. Another consideration is drainage. Establish trees for additional small drainage that goes underneath the driveway, and this is something to definitely keep in mind as we go through the planning. If this is going to be attached, we have some considerations. We've got the French drain there next to the house. We've got electricity that's already there. And we also have propane that's there as well. So that could either help or hurt us. This is an area that we need to consider as well. It gets moist here. It has a high water table in the spring. And then it dries out some. But we need to consider that, especially as we look at doing a climate battery. All right, now we've looked at the site itself, the orientation, and fully confident that we've validated where we want to put it, why we want to put it here, and why it makes sense to put it here, especially with sighting and orientation. The next thing I want to validate, and the final thing for this video, is mimicking a Mediterranean climate. Okay, we're here in North Idaho. We definitely are not a Mediterranean climate. We have, it's a cold climate. It's not extreme by any means. This is not Minnesota or North Dakota. We're technically, I should say, a zone 6, although we've gotten colder than that for sure. So not sure why we're really classified as a zone 6. However, if you look at this last winter, we didn't get down there at all. So we would definitely have been a zone 6 over this last winter. And so Mediterranean climate. So what is a Mediterranean climate? First of all, Mediterranean climate is obviously the climate that is predominant in the region of the Mediterranean, okay, around the Mediterranean Sea, the Mediterranean basin. Now there are things called analogs, which are basically other climates in other parts of the world that would mimic that. Okay, so the Mediterranean climate gets a lot of attention because of all the wonderful things that they grow there. With the figs and the citrus and olives and all of that wonderful stuff, we can grow in other places in the world. California is a great example, okay, of a California Mediterranean climate. Okay, now a Mediterranean climate is not some one thing. It's like, okay, this is what it is. Here's the average highs, here's the average lows, here's the precipitation. There's a wide swath of what is considered to be a Mediterranean climate. You have the coast of California, for example, that's a Mediterranean climate, and it's very mild and moderated because it's so close to the ocean. And then you have a little bit more inland, like the Central Valley, that is also considered to be a Mediterranean climate, but is vastly different from the coast. Much hotter in the summer and colder in the winter. All right, so we have that in mind, and so we, understanding that we can't specifically say this is what exactly the climate we're mimicking. So I'm mimicking in general a Mediterranean climate, but I'm also on the edge of the colder. Okay, and what I mean by that is I'm going to be closer to the Central Valley of California as opposed to the coast of California. The Central Valley, like I said, gets colder in the winter. Not super cold, it'll touch frost now and again, okay, here and there. And there's other places in the world, like I said, with these analogs that would do the same thing. There's places in Chile, the west coast of Chile. There's areas where, because it's higher in elevation, it gets colder in the winter. Again, it gets some frost, right? So and part of my thing here is I don't want to pump a bunch of energy in here just to keep something alive over winter. I want it to be energy efficient, which is why we're doing the cold climate greenhouse with insulation, etc. But therefore I'm going to mimic a Mediterranean climate, but on the colder side. So I am going to probably bring this thing down to 28 or 30 degrees. Okay, in the winter, because what are we doing? We are supporting plants in a dormant season. Okay, we're also going to be overwintering, more tender perennials of other kinds as well. So herbs, things like rosemary, things that are much harder to grow outside here, which on our microclimate here, we have not had success with that. I mean, we bring our rosemary inside in the winter. I'll put it that way. Okay, so this is something that could probably be a permanent fixture in something like a cold climate greenhouse. Okay, so therefore, now that we know what it is, why the Mediterranean climate, well, all the wonderful things that we can grow, that we can't grow outside here. And most importantly, I can mimic it here in an energy efficient manner. Okay, it would be, I think, foolish to try and mimic a tropical climate or even a subtropical climate here. It just doesn't make sense. We're putting way too much energy into it. And whereas if I go to a colder Mediterranean type climate, I think I can do that relatively easily and with very little input. Okay, so that's the goal, and that's why I believe that the vision is validated when it comes to what we're trying to do, the site we're doing it in, and all of that. Now, in the next video, I'm going to cover a few more things, and then we're going to tackle the problem of cost, because this is a huge factor. And so we're going to validate that and then get into a little bit more of the planning and hopefully be breaking ground here real soon.